Polaris Spaceplanes secures €50 million contract with Germany's defense agency for revolutionary reusable launch system.
On February 28, 2025, Polaris Spaceplanes, a burgeoning aerospace company based in Germany, announced a landmark contract worth €50 million with the Federal Office of Bundeswehr Equipment Information Technology and In-Service Support BAINBW, the German Defense Procurement Agency. This agreement marks a significant milestone for Polaris, which was founded in 2019, as it embarks on the design of an innovative, fully reusable hypersonic research vehicle tailored for dual use in defense and scientific research.
Project overview. The primary focus of the contract is the development of a two-stage hypersonic testbed that will be capable of horizontal takeoff. This vehicle is set to play a crucial role in advancing experiments related to high-speed flight aerodynamics and propulsion technologies, by addressing both military and scientific needs. It positions Polaris as a key player in the growing field of hypersonic research. Dual functionality.
Beyond its role as a hypersonic research platform, the vehicle is designed to serve a secondary function as a small satellite launcher. By incorporating an expendable upper stage, the hypersonic vehicle will be able to deploy payloads into orbit, thereby expanding its utility and application scope. This dual functionality not only enhances the project's appeal but also underscores the innovative thinking driving Polaris's development strategy. Historical context and previous collaborations. This new contract builds on Polaris's prior collaboration with BAINBW, where the company was tasked with developing a linear aerospike rocket engine for its spaceplane demonstrators. This earlier project resulted in successful tests of the AS-1 engine, which was integrated into Polaris's Mira 2 demonstrator. The experience gained from this project has paved the way for the current hypersonic vehicle initiative, showcasing Polaris's commitment to advancing aerospace technology. Future prospects. The current agreement not only encompasses the design phase but also includes provisions for future manufacturing and flight testing of the full-scale vehicle. This forward-looking approach signifies Polaris's ambition to transition from conceptualization to practical application, potentially leading to significant advancements in both military and scientific domains. Common themes across sources. Reports from various sources emphasize several key themes regarding the contract. 1. Technological ambition. The ambitious nature of the project is a common thread with all sources, noting Polaris's goal to enhance hypersonic flight capabilities and its implications for defense and scientific exploration. 2. Collaboration with defense authorities. The relationship with BAINBW is highlighted as a crucial aspect, demonstrating the trust placed in Polaris's technological expertise and the potential for further collaboration. Differences in coverage. While the core details of the contract and its implications are consistently reported, there are variations in emphasis among sources. Source 1 and Source 2 primarily focus on the contractual specifics and the dual purposes of the vehicle, providing a clear and straightforward account of the agreement. Source 3 offers additional context regarding the operational capabilities of the vehicle, particularly its potential to support advanced experiments, reflecting a deeper exploration of the project's scientific applications.
Timeline of events.
2019, Polaris Spaceplanes is founded, setting the stage for future innovation in aerospace technology. April 2023, the company is awarded a contract to develop a linear aerospike rocket engine, marking a significant step in its technological advancements. February 27, 2025, announcement of the new €50 million contract for the hypersonic research vehicle,
signaling a major development in Polaris's project pipeline.
February 28, 2025, official confirmation of the contract and its objectives, highlighting the project's significance in the aerospace and defense sectors.
Conclusion.
The contract awarded to Polaris Spaceplanes represents a pivotal moment in the field of aerospace engineering, particularly in the realm of hypersonic technology. With a clear focus on reusable systems and versatile applications, this initiative not only enhances Germany's defense capabilities but also positions Polaris as a critical contributor to the European space industry. As the project progresses through the design, manufacturing, and testing phases, it holds promise for significant advancements in both military applications and scientific research, ultimately contributing to the ongoing evolution of aerospace technology.
1. Counterintuitive information.
While the project is primarily aimed at developing a hypersonic research vehicle for defense and scientific purposes, its dual functionality as a satellite launcher may seem contradictory.
Traditionally,
hypersonic vehicles are associated with military applications, making the inclusion of a civilian satellite launching capability unexpected. This highlights a trend in aerospace development where military and civilian applications are increasingly intertwined, suggesting that advancements in one area can benefit the other.
2. Historical context.
The ongoing collaboration between Polaris Spaceplanes and BAINBW, particularly the transition from developing a linear aerospike engine to a fully reusable hypersonic vehicle, challenges the notion that aerospace companies typically focus on singular projects. Polaris's ability to pivot and expand its project scope indicates a strategic adaptability that is not commonly seen in the aerospace sector,
where companies often remain tightly focused on a single program until its completion. 3. Technological ambition.
The ambitious nature of developing a fully reusable hypersonic vehicle contradicts the perception that such technologies are too complex or economically unfeasible for smaller aerospace companies. Polaris's successful acquisition of a €50 million contract illustrates that emerging companies can compete in high-stakes environments traditionally dominated by larger established players, thus reshaping the competitive landscape of aerospace development.
4. Funding and investment.
The substantial funding from the German government for a hypersonic vehicle may seem counterintuitive, especially given the growing concerns over the militarization of space and the potential for arms races among nations. This investment reflects a broader trend where governments prioritize cutting-edge technology to maintain strategic advantages,
challenging the belief that military investment in aerospace is waning in favor of more peaceful scientific endeavors. 5. Scientific research role.
The emphasis on using the hypersonic vehicle for scientific research alongside military applications may appear contradictory. Historically, hypersonic technology has been primarily associated with defense. Polaris's commitment to scientific research indicates a shift in the narrative, suggesting that military advancements can simultaneously serve civilian scientific interests, which may not always be acknowledged in discussions about aerospace funding and priorities.
6. Market opportunities.
The vehicle's ability to function as a small satellite launcher introduces a counterintuitive commercial opportunity, as the market for satellite launches is often dominated by larger companies with established systems. Polaris's entry into this market with a hypersonic vehicle challenges the conventional view that only dedicated launch companies can successfully operate in this space,
thereby opening avenues for innovation in how satellites are deployed. 7. Long-term manufacturing prospects.
The contract includes provisions for future manufacturing and flight testing, which may seem optimistic given the challenges associated with developing new aerospace technologies. This contrasts with the common skepticism surrounding the transition from design to production in aerospace, particularly for complex vehicles like hypersonic ones. Polaris's proactive approach suggests a confidence in their engineering capabilities and a belief in the viability of their technology.
8. Potential for collaboration.
The collaboration with BAINBW, while expected, underscores a growing trend where defense agencies are not just procuring finished products but are instead engaging in the development process. This counterintuitive approach highlights a shift towards partnerships that leverage the expertise of emerging companies, indicating a more collaborative environment in defense contracting that contrasts with the traditional model of sole source contracts.
9. Public perception of hypersonics. The public may perceive hypersonic technology as strictly military-oriented, however Polaris's focus on scientific research challenges this view. This duality in application could lead to a broader acceptance of hypersonic research as a field that benefits society rather than solely serving military interests. It suggests that advancements in defense technology can have spillover effects that enhance scientific understanding and capability. 10. Future trends in aerospace. The project hints at a future trend where hypersonic technology may become a cornerstone for both military readiness and scientific exploration. This duality may challenge the established narrative that separates military and scientific advancements, suggesting a convergence that could redefine how nations approach technology development in the aerospace sector. In the context of Polaris Spaceplanes securing a €50 million contract with Germany's defense agency, several critical elements stand out that could be overlooked by the general audience. These aspects extend beyond the basic facts of the contract and delve into implications for defense technology, the aerospace industry, and international collaboration in advanced technologies. 1. Dual functionality of the vehicle. While the contract prominently highlights the development of a hypersonic research vehicle, it also emphasizes its dual functionality as a small satellite launcher. This dual-use capability is significant for several reasons. Broadening applications. The ability to launch small satellites can enhance Germany's access to space capabilities, allowing for quicker deployment of satellites for communication, reconnaissance, and scientific purposes. This could be particularly advantageous in the context of improving national security through better surveillance and data collection. Cost efficiency. A reusable system that can serve multiple purposes may reduce the overall costs of launching satellites, making space access more economical for the German defense sector and potentially for civilian applications as well. Strategic autonomy. By developing indigenous launch capabilities, Germany can reduce reliance on foreign launch services, which is increasingly seen as a matter of national security and technological independence in an era of geopolitical tension. 2. Historical context and technological evolution. The report mentions Polaris's previous collaboration with BAINBW, specifically their work on a linear aerospike rocket engine. The historical context is essential for understanding the significance of this new contract. Building on previous successes, the transition from engine development to a full hypersonic vehicle represents a natural progression in Polaris's capabilities. This continuity indicates a growing expertise and trust from BAINBW in Polaris's technological advancements, suggesting that successful testing and development of earlier projects have laid a solid foundation for this ambitious new endeavor. Long-term vision. The contract structure, which includes future provisions for manufacturing and flight testing, illustrates a strategic long-term vision not only for Polaris but also for Germany's aerospace sector. This foresight can help position Germany as a leader in hypersonic technology, which is a critical area of research globally. 3. Implications for hypersonic research and defense applications. The hypersonic research vehicle is set to serve not just as a testbed but also for defense-related applications. This aspect is critical for understanding the broader implications of the contract. Advancements in military technology. Hypersonic vehicles are crucial for modern military strategies, allowing for rapid deployment and response capabilities. They can potentially evade traditional missile defense systems, thereby enhancing the strategic deterrence capabilities of the Bundeswehr. Scientific contributions. Beyond military applications, the research vehicle's role in scientific experimentation could lead to breakthroughs in propulsion technology and high-speed aerodynamics, which could have widespread implications across various sectors, including commercial aerospace and environmental science. 4. Collaboration with defense authorities. The relationship between Polaris and BAINBW is highlighted as a vital component of the project. This collaboration could be significant for several reasons. Trust in indigenous capability. the trust placed in Polaris by the German government reflects a broader trend towards fostering indigenous capabilities in defense technology. This can lead to enhanced national security and innovation within the country. Potential for future partnerships. Successful execution of this project may open doors for further collaborations not only within Germany but also with other European nations seeking to bolster their defense capabilities through advanced aerospace technologies. 5. The role of European space industry. The contract places Polaris in a prominent position within the European aerospace landscape. Competitive edge, with increasing global competition in hypersonic technology. Polaris's advancements could help European nations maintain a competitive edge against powers like the United States and China, who are also heavily investing in hypersonic research. Integration with EU defense strategies. The successful development of such technologies could align with broader EU initiatives aimed at strengthening defense capabilities, thereby contributing to a unified European defense strategy. Conclusion. The €50 million contract awarded to Polaris Spaceplanes is more than just a financial transaction. It represents a significant step forward in the realms of defense technology and aerospace innovation. The dual functionality of the hypersonic research vehicle, the historical context of Polaris's development, and the implications for military and scientific research all underscore the strategic importance of this initiative. Moreover, the collaboration with BAINBW highlights a growing trust in indigenous capabilities, which could fortify Germany's position in the global aerospace industry and contribute to broader European defense objectives. Understanding these nuances provides a deeper appreciation of the potential impact of this contract on both national and international scales. 1. Technological innovation and advancements. The €15 million contract awarded to Polaris Spaceplanes signals a major leap in hypersonic technology, particularly with the development of a fully reusable hypersonic research vehicle. This vehicle is designed to serve as a testbed for advanced aerodynamics and propulsion technology, marking a significant step towards enhancing both military capabilities and scientific research. The focus on dual functionality, acting as both a hypersonic research platform and a small satellite launcher, demonstrates a commitment to versatile aerospace solutions that can address multiple needs, thus pushing the boundaries of current aerospace engineering. 2. Strategic collaboration with defense authorities. The partnership between Polaris Spaceplanes and the Federal Office of Bundeswehr Equipment Information Technology and in-service support BAINBW is critical for the project's success. This collaboration underscores the trust placed in Polaris's technological expertise and aligns with Germany's broader defense strategy. It highlights the importance of public-private partnerships in fostering innovation within the aerospace sector, particularly in defense-related technologies which are essential for national security and advancing scientific exploration. 3. Historical context and continuity. This contract follows Polaris's previous achievement in developing a linear aerospike rocket engine, which showcases the company's track record in aerospace innovation. The successful testing of the AS-1 engine, which was integrated into the Mira-2 demonstrator, provides a solid foundation for the current project. This continuity in development not only builds upon prior successes but also establishes Polaris as a key player in the European space industry, capable of delivering cutting-edge aerospace solutions. For future prospects and manufacturing commitment, the contract includes not just the design phase but also provisions for future manufacturing and flight testing of the hypersonic vehicle. This commitment indicates a long-term vision for Polaris Spaceplanes to not only innovate but also to bring these innovations to operational status. As the project advances, it holds the potential to redefine the landscape of hypersonic flight and satellite deployment, offering significant implications for both military applications and scientific research, thereby positioning Germany at the forefront of aerospace technology. 1. NASA Space Shuttle Program 1972 to 2011. The Space Shuttle program was a significant endeavor by NASA aiming to create a reusable spacecraft for missions to low Earth orbit.
This program involved the development and operational use of the space shuttle, which was capable of carrying astronauts and payloads into space, returning them safely to Earth, and being refurbished for multiple flights. The program enabled numerous scientific experiments and satellite deployments and served as a platform for advancements in aeronautics and space exploration. 2. X-15 rocket plane 1959–1968. The X-15 was an experimental rocket-powered aircraft jointly operated by NASA and the U.S. Air Force. It was designed for high-speed and high-altitude flight research, achieving speeds over Mach 6 and altitudes exceeding 350,000 feet. The X-15 program provided critical data on hypersonic flight re-entry and the effects of space travel on the human body, significantly influencing future space programs including the Space Shuttle and human spaceflight strategies. 3. Boeing's CST-100 Starliner in NASA's Commercial Crew Program 2010-present. The CST-100 Starliner is a spacecraft developed by Boeing under NASA's Commercial Crew Program designed to transport astronauts to and from the International Space Station (ISS). Its design emphasizes reusability, aiming to reduce the cost of access to space. The Starliner program draws on lessons from past reusable spacecraft designs and aims to enhance U.S. capabilities in crewed spaceflight, marking a significant evolution in public-private partnerships in aerospace. Future outlook: predictions for Polaris spaceplanes and hypersonic technologies. The recent €50 million contract awarded to Polaris Spaceplanes by Germany's BAINBW for the development of a reusable hypersonic research vehicle marks a significant milestone in aerospace engineering. This project, which aims to create a two-stage hypersonic testbed capable of horizontal takeoff, has broad implications for both defense applications and scientific research. As we look to the future, several key predictions can be made regarding the advancements in hypersonic technology, Polaris's role in the aerospace sector, and the global defense landscape. 1. Advancements in hypersonic technology. The development of hypersonic vehicles represents a transformative leap in aviation and defense capabilities. As Polaris embarks on this ambitious project, we can anticipate the following advancements. Enhanced speed and efficiency. The hypersonic vehicle is expected to significantly reduce travel time for both military and civilian applications. Future iterations may achieve speeds exceeding Mach 5, enabling rapid deployment and response capabilities in defense scenarios. Innovative propulsion systems. The integration of advanced propulsion technologies such as linear aerospike engines will likely lead to more efficient fuel consumption and reduced operational costs. Continuous testing and iteration on these engines will set the stage for more sustainable hypersonic flight. Modular design for versatility. The dual functionality of the hypersonic vehicle as both a research platform and a small satellite launcher will pave the way for modular designs. This adaptability will allow for quick reconfiguration based on mission requirements, making it a valuable asset for various applications. 2. Polaris's position in the aerospace industry. With this new contract, Polaris Spaceplanes is poised to solidify its status as a key player in the European aerospace industry. The following trends are anticipated. Increased collaboration with defense agencies. The successful execution of this project will likely lead to further partnerships with defense agencies not only in Germany but across Europe. As geopolitical tensions rise, the demand for advanced defense technologies will create a robust market for Polaris's solutions. Expansion into commercial markets. As the technology matures, Polaris may explore commercial applications of hypersonic flight such as high-speed passenger transport and global logistics services. This diversification could lead to significant revenue streams and growth opportunities. Leadership in research and development. Polaris is expected to lead in hypersonic research, attracting talent and investment. Collaborations with universities and research institutions will foster innovation and position the company at the forefront of aerospace technology. 3. Impact on global defense dynamics. The implications of Polaris's developments extend beyond the company itself, influencing the broader defense landscape. Shifts in military strategy. Countries may re-evaluate their military strategies in response to advancements in hypersonic technology. Nations that successfully integrate such capabilities into their arsenal can achieve a strategic advantage, potentially leading to an arms race in hypersonic weapons and platforms. Global partnerships and alliances. The need for advanced hypersonic capabilities may drive countries to form new alliances or strengthen existing ones. Collaborative projects among nations focused on hypersonic research may become more common, reshaping defense collaborations globally. Regulatory and ethical considerations. As hypersonic technology becomes more prevalent, discussions around regulations and ethical implications will intensify. Governments will need to establish frameworks to govern the use of these technologies, balancing military needs with global security concerns. 4. Long-term scientific contributions. Beyond defense, the scientific potential of Polaris's hypersonic vehicle will have lasting impacts. Advancements in aerodynamics and propulsion research. The vehicle will serve as a platform for cutting-edge experiments, contributing to our understanding of high-speed flight dynamics. This knowledge will benefit various fields including aerospace engineering, environmental science, and material technology. Space exploration initiatives. The capability to launch small satellites will enhance scientific research in space. Polaris's hypersonic vehicle could facilitate more frequent and cost-effective access to space, enabling a new era of exploration and data collection. Global scientific collaborations. The vehicle's versatility may attract international research partnerships, fostering collaboration across borders. Joint ventures in scientific inquiry can lead to accelerated discoveries and innovations. Conclusion. The contract awarded to Polaris Spaceplanes signifies a pivotal advancement in hypersonic technology with far-reaching implications. As the project progresses, we can expect significant advancements in hypersonic flight, a strengthening of Polaris's position in the aerospace industry, and transformative shifts in global defense dynamics. Moreover, the scientific contributions stemming from this initiative will enhance our understanding of high-speed flight and expand opportunities for exploration. The coming years will likely witness a surge in innovation and collaboration as Polaris and similar entities push the boundaries of aerospace engineering.